Hello students, a very good evening and welcome to Turito. In today's lecture we are going to learn a new concept which is non-negative integral solutions of a certain equation. So this is very important idea and concept of this chapter. This idea has lot many applications in your future also. So today we will take up some of the applications, but later on if you understand the idea and if you understand the method, you can always apply it to any different kind of situation also. Okay, shall we start? So before we go ahead, we have to first build the concept. Okay, so in every concept we have to, whenever we study any concept, we have to build it from the scratch. So we will build it from the scratch, and this becomes our standard equation of finding non-negative integers. So whenever questions like these come, they generally ask you about how many non-negative integral solutions are there. They don't ask you about what are the solutions, they will ask about how many solutions are there. So how do we proceed with this? So first thing that you have to understand here is the number of variables. Okay, so here how many variables are there? R variables are there. Okay, so R becomes the number of variables. Okay, and n becomes the total summation, sum of variables. Okay. Now I will write the formula here and I will derive the formula in the next pages. The formula is going to be n plus r minus 1 c r minus 1. It is a standard formula. Also in the earlier lecture of using binomial theorem to solve questions, we have also solved one such question. Okay, so where 3 variables were there and sum of those 3 variables was equal to 10, x plus y plus z equal to 10. We solved it, we got the answer also, but today we are going to generalize it. Okay. So how do we solve this problem? There are actually 2 major methods. Of course there is one more minor method which is making the cases, but that is too long. What if n is very big? Of course you don't want to make so many cases. So that is a minor method. 2 major methods are there. So one is the usage of the multinomial theorem. Second is using the balls method or flags method or sticks method, or also called as the gaps method. Okay. So let us try to first solve it using multinomial theorem idea, and then we will go back to the idea of the balls method or flags method or gaps method. So how do we do this? So for every variable, if we check the possible values, the possible values here are going to be, so basically I am writing a statement here that xi must be belonging to, starting from 0, it can go up till n. Okay. So we are looking for the non-negative integral solutions, so that means integers cannot be negative, they can be 0, they can be positive also. So these are the possibilities. Now if 2 has certain chances of coming, 3 also has the same chances of coming. Okay. For example, I can take x1 equal to 2 in one way, I can also take x1 equal to 3 in one way. So every number here has one way of coming. Okay. So that means for x1 I will be writing a function like this: p raised to 0, p raised to 1, p raised to 2 until p raised to n. So here power is representing the value of x1 and the coefficient is representing in how many ways that value will come. Okay. So this way I have written one polynomial for x1. Now similarly I will write a polynomial for x2 also, and that will also be exactly same. For x3 also same polynomial, for xr also same polynomial. So there are how many such polynomials? R such polynomials. When we multiply all of them, we will be getting raised to r. Now what is the meaning of this polynomial here? So just imagine that there are r factors here. Okay, so let us say this is factor 1, factor 2, factor 3 and so on. There is one more factor. Now from here if I take any certain term, that term will look like p raised to x1. From here if I take a certain term, it will look like p raised to x2, and from here if I take any term, it will look like p raised to x3. Similarly, from here if I take any term, it looks like p raised to xr. Now we are going to multiply them, right? So whenever we multiply few factors, what is going to happen? All terms involved in those factors are going to get multiplied, okay? So we will be getting a product like this, which also means that it is p raised to x1 plus x2 plus x3 till xr, okay? So now by taking this, what do we want? We want sum of all these variables to be equal to n. So which means basically I am looking for the coefficient of p raised to n. That's my target. So from here I am going to get coefficient of p raised to n. So here I have actually explained you why we are looking for the coefficient of p raised to n. If you understand this logic, you understood everything, okay? Now let's go back to this. How do we solve this? We have to go for some ideas of binomial theorem. So we'll borrow those ideas and we'll put them here. So I can simplify the base as 1 minus p raised to n plus 1 divided by 1 minus p whole raised to r, which also can be written as 1 minus p raised to n plus 1 raised to r into 1 minus p raised to minus r. I am going to expand this using normal binomial theorem and this using negative binomial theorem. So how do we do that? I will be writing just two terms here. So it is going to be 1 minus rc1 into p raised to n plus 1 and so on. And for this, how do we write the expansion? That I have already explained in the earlier lectures also. So what are the terms going to be? 1 plus, it will start with rc1 into p, and the next term it will start with r plus 1 c2 into p square, and the next one will start with r plus 2 c3 into p cube, and so on, it keeps on going, right? So now what will be the general term here? So that means I have to look for a general power. Let's say it is p raised to k. So whenever p raised to k comes, observe the pattern here, it should be ck. So here it should be ck. Now observe the gap between these two. Gap between these two is always r minus 1, okay? So we have to add r minus 1 to this k. So r minus 1 plus k ck into p raised to k. That's our general term. Now what is our goal? Our goal is to get p raised to n. So here if you observe, except the first term, all other terms have higher powers than n. So these are already exceeding n. So these will not contribute anything towards our goal, which is p raised to n. So you can ignore all of them because we don't need them, okay? Now coming to the others, if I am taking one here, I have to pick p raised to n from here. So that means I have to put k equal to n and get the coefficient. So what will be that coefficient? R minus 1 plus n Cn. This is our coefficient, okay? So basically we got n plus r minus 1 Cn, which can also be written as n plus r minus 1 Cr minus 1. Now how did we get this? By using the idea of binomial theorem, that NCr is equal to Ncn minus r. So using that idea we can definitely derive this, okay? So this is the idea of using binomial theorem to solve the question. I hope you understood the workout here, okay? Come on, make a note of this. Okay. Now the same problem I am going to solve using our balls and sticks or flags method. Okay. So how do we proceed here? Now imagine that there are R groups. Okay. So there are R groups. You can take them as groups or boxes or rows. It does not matter. Okay. And you want to arrange these n. What do we take n as? Let's take them as some identical objects or balls, okay. So I can take n identical objects or balls, okay. Or you can also take this as n ones, okay. So you can also take this as n ones, okay. And these R groups means you want to divide these n balls into R groups, okay. So in how many ways you can do that, that's the whole point. So what we do is, let's say we arrange these n balls in a straight line, and I have taken a stick and I am going to place the stick in between the arrangement. So wherever I am placing the stick, how many ever balls are there before that stick will go to the first group, and whenever I place the next stick between these two sticks, how many ever balls are there, they will go to the second group, and so on, okay. So that is basically equivalent to placing how many flags, R minus 1 flags, okay. So here the arrangement is some kind of arrangement like this, okay, where I am basically placing some sticks or flags here, okay. So let's say there is one flag here, and let's say there is one flag here, and there is one flag here. So what does this represent? It represents that x1 is equal to 1. So it's actually the count of the balls, okay. Now x2 is going to be 2. Similarly, x3 is going to be 4, okay. Now let's say there is one flag here. Now after this, how many balls are there? There is only one ball, okay. So let's say there is one more flag here. So this is our x r minus 1, it should be 4, and here x r should be 0, okay. So this way we can understand the main idea of this flags. So how many flags are we taking? We are actually taking r minus 1 flags, okay. So we can take, if there are r groups, we are going to take r minus 1 flags, okay. So we are taking r minus 1 flags here, okay. So I am going to arrange these r minus 1 flags and these n identical balls in a straight line. So if I randomly arrange all of them, then every arrangement is going to represent something, okay. For example, let's say there is one more flag here and these flags are together. What does it mean? It means that x5 is going to be 0, okay. So basically these flags are actually representing the variables here, okay. But only thing is we are having one unit less number of flags, okay. So when we arrange balls and flags together, we are going to get some values of x1, x2, x3 till xr. The minimum value of these will be 0, maximum value will be n. How do we understand that? Let's say all flags are at the end, and in front, in the beginning, all n balls are there. What does it mean? x1 equal to n, and all other variables x2, x3 till xr, all of them are zeros. This is what it means. So whenever we are applying the method, we have to also make sure that we are covering all cases. So this way I have taken all possibilities, I have explained you the logic behind this, okay. Now that I explained the logic, problem solving is simple. How do we solve the problem? Just count in how many ways you can arrange them, okay. So in how many ways we can arrange them? There are n identical balls and r minus 1 identical flags, right. So if you go by the macro method, so how do we arrange them? N minus r plus 1 factorial divided by how many balls are there? N balls are there, all are identical, so n factorial, and how many flags are there? R minus 1 flags are there, so we will be writing r minus 1 factorial here, okay. So for n identical balls there is n factorial, for r minus 1 identical flags there is r minus 1 factorial, okay. So you got n factorial, you got r minus 1 factorial. This is our macro method of arranging them. But if we go by the other idea of micro method, so that means we will imagine that there are n plus r minus 1 seats, and out of them we want to select any r minus 1 seats, place the flags there, and in the remaining place the balls. Or you can do the balls arrangement first, then the flags arrangement, it does not matter. So let's say from these n minus r plus 1 locations, okay, from these n minus r plus 1 locations, I am going to select how many locations? I am going to select r minus 1 locations, and I will arrange r minus 1 flags in one way, and I will arrange the remaining n balls also in one way. So it is just this number. So this number and this number both are going to be exactly equal. Okay, so these two numbers are going to be exactly equal, and this will basically represent the total number of non-negative integral solutions of this equation. Okay, so so I hope you understood this balls and flags method. Okay, we can also apply ones and zeros idea here. Okay, so for example, let's imagine that there are n ones. Okay, and let's imagine that there are r minus 1 zeros, and you are going to arrange these zeros and ones, and these location of zeros will represent the number of these variables. Okay, so for example, here let's say we have 1 0, we have 2 ones here, we have 0 0, and we have 4 ones, and so on. So what does this represent? Before this 0, how many ones are coming? There is no 1, so x1 is 0. Now between these two zeros, how many ones came? 2 ones came, so x2 is 2. Now between these two zeros, how many ones came? No ones, so x3 is 0, and here how many came? 4, so x4 is 4, and so on. So this way you can actually arrange all of them. So this is also equivalent to arranging n ones and r minus 1 zeros, because you know that sum of all of them should be n. So you are basically dividing n ones, you are basically dividing n ones in r groups. Okay, so this way also you can understand it. Okay, so this is basically flags method, gaps method, sticks method, all of it. So there are two ideas of understanding these integral solutions, whether it is non-negative or positive. So one idea is to go for the binomial method, other idea is to go for this method. Okay, both are helpful. One method works sometimes, other method will work sometimes, both will work sometimes, and both cannot work together sometimes. So that is why you have to learn both methods, because when one does not work, you can apply the other. Okay, come on, make a note of this. Okay. Now that we have understood the basic idea of non-negative integral solutions, now let us understand the idea of positive integral solutions. Okay. Suppose let us say we have positive integral solutions and we want to apply the gaps method. So how do we understand here? We understand that we are basically arranging n ones in a straight line. Okay. So n ones or n balls. Okay. And we are going to put r minus 1 zeros, okay, or r minus 1 flags. So r minus 1 zeros should be placed in such a way that between every two zeros there is at least one 1, okay. So that means between every two zeros there should be at least one element there, okay. And also zeros are not coming at the end, or you can also put the flags. So we have to put flags only in these gaps, okay. So how many such gaps are there? If there are total n ones, how many gaps are there? Only n minus 1 gaps are there. Okay. So we can select any r minus 1 gaps from these n minus 1 gaps and place the flags in them in one way. So this becomes our total number of positive integral solutions. So here if you observe, we did not take the gap here, we also did not take the gap here. Okay. Because if flags comes in the very beginning, it means x1 is becoming 0, which is not allowed, because minimum value of x1 is 1. Okay. So there should be at least 1 before we put the first flag. Okay. So this way we can understand the idea of positive integral solutions. Okay. So here I have explained you how to do this question using the gaps method. Okay. Now let's say you want to apply the binomial method. How do you do it? You have to write a function for every variable here, and the minimum value is 1 only, because we are looking for positive integral solutions. So our polynomial will start from p raised to 1, okay, and then we will write p square, p cube, and so on till p raised to n. And how many such variables are there? R variables are there. So this is raised to r, and what are we looking for? Coefficient of p raised to n. okay, and that will come out to be the same value, okay. So, which is going to be n minus 1 C r minus 1, or you can also write it as n minus 1 C n minus r. You can also do it this way, it is the same thing, okay. So, either way, either you go by binomial idea or this idea, answer is going to be same, but remember that this is actually a lengthy method, but this is a faster method, okay. But remember, also remember this, that all fast methods do not work always, okay. When there are too many special cases, fast methods fail, and these micro methods which give more details will work out, okay. So, this is one idea, you can definitely make a note of this. Okay. Now, let us try to apply a different idea here. This idea is called as the idea of dummy variables. So, I am going to introduce some dummy variables here and solve this, okay. So, this is even faster than the earlier idea, but to solve this, of course, GAPS method works faster, but I am giving you idea. So, in this question, idea is more important than the solution. So, this idea will work faster in the other problems, okay. So, how do we start here? What is the minimum value of x1? It is 1, right? But we have a formula. What is the formula? Formula is n plus r minus 1 Cr minus 1. What does this represent? It represents the total number of non-negative integral solutions, okay. So, this represents non-negative integral solutions, and what is n here? It is sum of variables, okay, sum of variables, and what is r here? It is the number of variables, right. So, if I am able to convert this problem into a problem of finding non-negative integral solutions, then I can apply the formula. So, this entire method of dummy variables is focused on converting the equation into an equation where I can apply the formula. This is the main idea of this method. So, how do we convert this? We are going to introduce one new variable for every variable here, because x1 has minimum value of 1. So, I will write x1 as x1 dash plus 1. This is my x1, okay. And again x2 will be written as x2 dash plus 1. Similarly, x3 can be written as x3 dash plus 1, and so on, and xr can be written as xr dash plus 1, and this summation should be n. Now, what are the conditions on this? Because you wanted x1 to be greater than equal to 1, and what is the relation here? Relation is x1 is equal to x1 dash plus 1, right. So, in a way you are actually putting the condition on x1 dash that it can be 0 also. So, when x1 dash is at 0, x1 will be at 1. When x1 dash is at 1, x1 will be at 2. So, this way you are making sure that this condition is satisfied, and also x1 dash becomes the non-negative variable, whereas x1 becomes the positive variable, okay. So, basically you are getting this idea of non-negative integers here, okay. So, the new variables that I introduced here can be non-negative, but the old variables are strictly positive, okay. So, what this transformation has helped us with? Transformation has helped us with the problem's condition that it should be positive integral solutions. It has helped us, and also it has helped us in applying the formula, okay. So, now we just have to apply the formula directly, okay. So, for that, first count how many ones are there, okay. How many ones are there? Total there are r ones, okay. So, we can write this entire equation as x1 dash plus x2 dash plus x3 dash and so on till xr dash is equal to, how many ones did I take? I took r ones. So, from n I have to subtract r because I am taking these r ones to the RHS. So, it becomes n minus r here, okay. Now, how many variables are there? R variables are there. Now, what is the sum of all variables? It is n minus r. So, when we apply this formula, in place of n, n minus r should come. Okay. So, number of non-negative integral solutions of this equation, okay, non-negative integral solutions of this equation will be n minus r, this is in place of n, now plus r minus 1, c r minus 1. So, if you here luckily r is getting cancelled. So, if you cancel out r, what remains is n minus r c r minus 1, which is same as our earlier formula. Okay. So, this way we can introduce some variables which are the dummy variables. You can use the dummy variables and solve this problem. Okay. So, now in this explanation what you have to register is about the dummy variables, not about the method and the answer. Of course, it should match, but idea is these variables. Okay. Come on, make a note of this. Okay. So, now that we have understood the basic ideas and concepts, let us look at the formulae that we have derived. For this equation, this becomes our standard equation and these two become our standard formulae. Okay. So, for non-negative integral solutions, formula is n plus r minus 1, c r minus 1. For positive integral solutions, it is n minus 1, c r minus 1. Okay. Now, here we also tried to prove this from the earlier idea only by using the dummy variables. Okay. So, we learned all methods, we learned only two formulae. Okay. So, I can also just give these two formulae in just 2 minutes in the first page, but it is not like that, you have to learn the methods first. Okay. Now, let us solve some problems based on these ideas. Okay. So, this is purely skill development stage. So, we learned the concept, now we are going to develop some skills. Okay. So, there is an equation here and the question is about non-negative integral solutions. So, if condition was not there, then the problem is direct, you can apply the formula and solve it. Okay. But here problem is not direct. Okay. So, if we directly want to use the formula, this is the formula. Okay. But we cannot still directly use it because there are conditions. Now, to avoid the conditions, we will use dummy variables. So, for x I am going to write x dash plus 1 because I want minimum value of x to be 1 and that way I am allowing x dash to become 0 also. Okay. Similarly, for y also I am going to write y dash plus 2 now. Okay. So, when y dash is at 0, y becomes 2. Okay. So, that way I am allowing y dash to become non-negative. Okay. Similarly, for z also I will be writing z dash plus 3 and this summation should be equal to 20. Now, take these three numbers to RHS. So, it becomes x dash plus y dash plus z dash is equal to 20 minus 1 plus 2 plus 3 is 6. So, that means this is 14. Now, how many variables are there? 3 variables are there. So, r is equal to 3. What is the sum of all variables? It is 14. So, we can apply the formula. So, it becomes 14 plus 3 minus 1c, 3 minus 1. So, the answer is 16c2. Okay. So, this way we can solve it very fast using dummy variables. I hope you digested the idea. But whether you are using gaps method or dummy variables method, all these questions can also be solved using binomial method. Binomial is like superset and these are actually subsets which work only on certain type of questions. Okay. Come on, make a note of this. Okay. Now, let us have a look at another problem. Here, how many non-negative integral solutions of this equation exist? So, what are the minimum values of x, y, z here? Minimum values can be only zeros, but what about maximum values? Can we say that the maximum value is 5? Just have a look at this. We can't say that the maximum value is 5, okay? Because let us say if x and y are 5, z can be equal to 5, then summation will be 5. But if x and y are 10 each, 10 here, z can be 15. If x is 100, y is 200, z can be 295, then also it is possible. So there is no limitation of the maximum value. So which means values can go up till infinity also. So for this question, the answer is going to be infinity. Okay, so it may look silly, but what you have to note here is the negative sign. Whenever there is a negative sign, then it's highly probable that number of solutions will be infinity. So please be careful when you are handling such questions. Okay. Okay, so now let's solve another problem. Here we have to find the non-negative integral solutions of this equation, but the only change is the coefficient. Okay. So whenever there is a coefficient, what is the idea here? There can be two ideas, because this is now breaking our basic stereotype, so we cannot use dummy variables. Okay. So here dummy has failed. Okay. So dummy variables we cannot use. What are the other methods? Gaps method also will fail, because strictly you have to maintain the last variable to be a multiple of 4. That will be a confusing one. But then what will work out? Binomial method will still work out, and also making cases, which is our fundamental method that we learned in the initial lectures, that also will work. Okay. So if you make cases, you can take help of the formula and solve it. Okay. So this is another idea. We are going to solve this problem using these two ideas. Okay. So how do we approach? Let's say I go for binomial method first. So for these three, I will be writing a function like this, 1 plus p square till p raised to 10, because maximum value can be 10 only, and there are three such similar variables, so raised to 3. But this fourth variable has a limitation. Whenever a w's value is taken, its contribution towards the summation is 4 times. Okay, so its contribution is 4 times. If I take w to be 1, its contribution to the total is 4 into 1. If I take w to be 2, contribution to the total is 8. So there is always a factor of 4 there. So we modify the function as 1 plus p raised to 4 plus p raised to 8. So here I am taking multiples of 4 in the power. Okay. Now I am ending it right here, because next multiple of 4 is p raised to 12, but 12 means summation must be 10, so that means we are actually exceeding 10. So 12 is not allowed. Okay. So now we are going to collect coefficients of p raised to 10. So how do we do it? I will just take this in the left side. So 1 plus p raised to 4 plus p raised to 8 into this I am going to simplify. So this is a standard GP, right? So 1 minus p raised to 11 whole cube into 1 minus p raised to minus 3. Or one more step I will write. So here it is going to be 1 minus 3 into p raised to 11 plus 3 into p raised to 22 minus p raised to 33. This is a minus b whole cube. Okay. And here it is going to be 1 plus 3c1 into p plus again 4c2 into p square, and so on. This will go on. Now what will be the general term here? When I take the power to be, let's say, r, then we should be getting CR here. And what is the difference between n and r here? 3 and 1, 4 and 2, difference is 2 units. So I will be writing r plus 2 here. Okay. So now further, what is our goal? Our goal is to get p raised to 10. Now when I am taking 1 from here, I have to take p raised to 10 from there. What about this term? We can ignore all these 3 terms. Why? Because they have already exceeded p raised to 10. So for the solving purpose, we can ignore all of them, because they are not contributing anything. So here from this factor only 1 is coming. Okay, so we can take only 1 from here. So when I am taking the first term 1 here, I have to take p raised to 10 here. So put r equal to 10, what do we get? You will be getting 12c10. Okay, so this is going to be our answer. We are going to collect other terms. And here there is p raised to 4. When I am taking p raised to 4, I have to take p raised to 6 from here. So put r equal to 6 in that. So that will give me 8c6, right? So we are adding it. And again p raised to 8, so this coefficient is 1, and here we have to take p square, so that the product becomes p raised to 10. Okay, so when I take p square, I am getting 4c2 here. Okay, so this will be our required value. Okay, so this way we can still solve this problem using binomial theorem. Okay, that is the beauty of the method of multinomial theorem or binomial theorem. It will work even if all other methods failed. Okay, so that is why you have to learn this method. It's very important. Okay, so when all others are failing, go for this idea. If others are working, use those ideas. Okay, because this is a lengthy method, so we generally do not recommend. But if others are failing, then use this method. Okay, now let's go to the making cases method. Okay, so here whatever is having the highest coefficient, we are going to guess that number. Based on that, we'll make cases. Okay. For example, let's say I take w equal to 0, okay, then x plus y plus z can be equal to 10. Now with this condition, how many solutions will come? We have understood the formula here. So here it is going to be 10 plus 3 minus 1c, 3 minus 1, which is same as 12c2. Now let's say w is equal to 1. So this means x plus y plus z must be equal to 6, because contribution of w is 4 times. Okay, so 4 into 1, if we subtract this from 10, only 6 is left. Okay, now again when we apply the formula here, so we will be getting 6 plus 3 minus 1c, 3 minus 1, which is 8c2. Now again I will take w equal to 2. So what do I get here? X plus y plus z equal to 2. Again the same formula. So this applying the formula will give us 4c2. When we add these three numbers, we are going to get our total number of solutions. Now have a look at this. This case, this value and this value must be equal. So whatever the cases that we have taken here are basically the terms that we have taken here. Whenever I was taking 1 here, that means I am taking w equal to 0. When I am taking p raised to 4, I am taking w equal to 1. So this way, these two ideas using binomial theorem and making cases are actually one and the same. Okay, so this way you can understand the methods here. Okay, so I hope you understood this idea. So please make a note of this. This page also. Okay, so now let's have a look at another problem. Now this problem is little more interesting, okay, because here it's not exactly equal, it is less than 100. So how do we approach this? So one thing is clear, that x has to be greater than 4, y has to be greater than 5, so that means x is greater than equal to 5 and y is greater than equal to 6. So a condition on minimum value came. So we are going to use dummy variables. Okay. So we can use dummy variables here. Then what happens? I will be writing x as x dash plus 5 and I will be writing y as y dash plus 6. So here x dash and y dash can become non-negative. So when I use it, what will happen? Okay. Now I am going to take this 5 plus 6 to the RHS. Then it becomes x dash plus y dash plus z plus w is less than, when we subtract 11 from 100, it's going to be 89. Okay. So here x dash, y dash, z and w, all these four variables can be non-negative, but they can, this summation cannot be exactly equal to 89. So what can we say? We can modify this and we can write this as x dash plus y dash plus z plus w is less than equal to 88. So it means the summation can be 0 or 1 or 2 or 3 and it will go till 88. So we are basically solving a question like this: x dash plus y dash plus z plus w, okay, is equal to n, and where the value of n is varying from 0, 1, 2 till 89. Okay, so value of n must vary like this. So now how do we use it? We can directly apply the formula and get it. Suppose let's say if I take n equal to 0. Okay, so before that let me just write a formula for this. Okay, so what is the formula? N plus 4 minus 1 C 4 minus 1, this is the formula, right? So it becomes n plus 3 C3. Now value of n is varying from 1 to 89. So basically our answer is going to be sigma n plus 3 C3, and n is varying from 0 to 88. Okay. So here it must be 88, my mistake. Okay. So this means what are the terms which are going to be? Now let's put values and see. So if I put n equal to 0, I will be getting 3C3. If I put n equal to 1, I will be getting 4C3. If I put n equal to 2, I will be getting 5C3, and so on, and till the last number, which is when I put 88 here, I will be getting 91C3. So it will go up till this number. Okay. Then you have to find the summation of this using some idea or other idea of binomial series. So using binomial series sometimes can be a lot of tricky problem, okay, but still you can still solve this using binomial series. Okay. For example, if you use this idea that NCR plus NCR plus 1 is equal to n plus 1 CR plus 1. If you use this idea, you are going to get the summation here, okay, and it must be equal to, when we simplify this, it must be equal to, I will write the answer here, 92C4, it must be equal to 92C4, okay. You can try finding the summation of this using binomial series and especially using this property, okay. But then I have a better idea to solve this problem. The idea is now to introduce another variable which is even dummier than the dummy, okay. So I am going to name this as slack variable, okay. So I will name this as slack variable. So this is a very standard idea, you will learn this in future also. Probably you will not learn it unless you touch that subject on your own, okay. So there is an idea of slack variable, okay. So slack means after you cut certain parts, whatever is left out is the slack, okay. For example, let's say you are eating pizza and all people have eaten, let's say 7 pieces and there is 1 piece left, it becomes the slack, okay. So whatever is left over becomes the slack, okay. So here after we got this equation, I am going to deviate the problem into a different idea, okay. So here x dash plus y dash plus z plus w was less than equal to 88, right. And here this means x dash plus y dash plus z plus w, sum of all these 4 variables may not be exactly 88. It may be equal to 88, it may be 87, it may be 86 and so on, it may be 0 also. But then whatever is the value that is remaining, I am going to name that as the slack variable, okay. So I am going to introduce one slack variable here which is s, okay. So when I introduce s, the equation will become somewhat like this, okay. Now what is this s doing? It is actually taking over all the remaining numbers which are left over, okay. This is like junk or trash, okay. So whatever is left out is my s. So now these are the 4 which are actually taking certain values. Now I have designed a new variable for the leftover values. So that means sum of all of them must be equal to 88. Now use the formula, okay. So what will it become? There are 5 variables here. So 88 plus 5 minus 1, C5 minus 1. Okay, this is the formula. So then it becomes 92 C4, which is exactly same as our earlier problem. Okay. So instead of going for the binomial series summation, you can also go for the slack variable here. Slack will solve it faster. Okay. Come on, make a note of these two ideas. Okay, this also. Now let's have a look at another problem. Okay. So here how many non-negative integral solutions are there for this equation? And if you look at the variables, all 4 variables must be belonging to this set. So if you look closely, this question is similar to this question of 4 dice. Okay. When 4 dice are rolled simultaneously and when you wanted sum of all outcomes to be equal to 12, in how many ways this sum of all outcomes is 12? That question and this question are exactly same, right? Because here all numbers are equally likely. So on the dice also all numbers are equally likely. So this question and this question are exactly same. So that is why it's better that you connect all questions and see that all are having the same method. Okay. Now how do we solve this? So here there is a minimum value which is 1. So you can think of using dummy variables, but there is a maximum value also. When there is a limitation on the highest value, we cannot use dummy variables. So dummy variables also flopped. So in this particular question, our flags method failed and our dummy variables failed, and also of course formula will fail. Okay. So then what will work out? Only binomial will work out. You can also make cases, but making cases is too long here. Okay. So whenever in these kind of questions, if we are making cases, we generally fix one value to be certain value and then we will apply the formula on the remaining. But to apply the formula on the remaining values should not have any conditions. But here every variable is having a condition. So we cannot use making cases also. So the only method which will work is the binomial method. So how do we do it? We write polynomial for all dice. So let's say for one dice if I write polynomial, it will start from p raised to 1, p square, p cube, p raised to 4, p raised to 5, p raised to 6. This is for the first dice. And then there are how many dice? 4 dice. Okay. And we are going to collect the coefficients of p raised to 12. Okay. So our goal is to get the coefficient of p raised to 12. This is going to be our answer. Okay. But then how do we solve this? Okay. So I am going to leave this to you. I will write the answer directly. Okay. So when I am simplifying this, I will get p raised to 4 common, and here there will be 1 minus p raised to 6 raised to 4 and 1 minus p raised to minus 4. So there is already 4 here. So we have to expand this. So it becomes p raised to 4 into 4c naught minus 4c1 into p raised to 6 plus 4c2 into p raised to 12, right? And here the general term is going to be for this r plus 3 cr x raised to r. This is our general term. Okay. Now let me see, we want p raised to 12. So when there is 4 here, we have to take p raised to 8 from here. So when I am collecting 4c naught here, I have to take p raised to 8 here. So put r equal to 8, it will become 11c8. And when I am taking minus 4c1 here, my goal is to get p raised to 8 from here. So I have to take p raised to 2 here. So put 2 there. So it becomes 5c2. That's it. This is going to be our answer. Okay. So just check if you are getting this answer or not. Okay. Now let's move on to the next question. Now let's solve one interesting question. Okay. So here the question is about selecting any 2 people from an already arranged 10 people in a row. such that those two are together in one problem and not together in the other problem. So let me solve one problem here, okay. So let's say there are 10 balls here, okay, they are already arranged, okay. We want to select any two balls so that they are always together. So how many such cases are possible? So we have to select couple seats basically. So there is one couple here, one couple here, like this. If I take the couples, how many couples are possible? 9 couples are possible. So the answer is 9. Okay, this is our first part. Okay. Now let's go to the second part. Here we want to select two of them so that they are not together. See, this is easy, but this is little tough. Okay. So how do we understand this? We understand this as selecting one and making sure that the other one is not adjacent. But that is going to take lot of time, because if you make cases for every person, it will be different for the edges and different for the middle guys. So it will be little confusing, but still you will get the answer. Okay, you can still do that. So here what I am going to do is, I am going to subtract this from the total. That way also I can get, okay, so from any 10, in how many ways I can select any 2? 10C2. From 10C2, if you subtract the together case, you will get the not together case only. So second problem can also be done this way. Okay, so this is one way. I can take this as M1. Okay, so we can take total minus 9. Okay, or there can be another method which is M2. This comes from the arrangement. Let's say you want your selections to be black balls and you want your non-selections to be white balls. Okay, so let's imagine like that. So there are here, how many white balls are there? There are total 8 white balls are there. Okay, and you have 2 black balls. Okay, so you have 2 black balls. These are shaded balls. When you arrange all these 10 so that these two are never together, then how do we do that? First you arrange these 8 guys in how many ways? In one way, because all are identical. So see, the problem is selecting people, but here the problem that I am solving is the arrangement. But I am going to map this problem with that problem, so keep watching. So here there are 10 identical balls, 2 identical balls, these are black, these are white. Okay, so I arrange these in one way, and then I will select any 2 gaps to make sure that these two are not together. Okay, so in how many ways I can do that? How many gaps are there? 9 gaps are there, including the ends. Okay, so in 9C 2 ways I will select any 2 gaps and arrange those 2 black balls in one way. Now what is this 9C2 representing? It is representing the total number of selections of the gaps for the 2 black balls such that those two are not together. So this you can map to the original question, that this 9C2 represents the total number of selections of any 2 people so that they are not together. Okay, so this means you can imagine also this way. Okay, so suppose let's say there are 10 people here. Okay, and there are 10 seats here. Okay, 10 people are that side, 10 seats are here. So I have taken total 8 white seats and 2 black seats. So white seats are identical, black seats are identical. I arranged these 10 seats in such a way that no 2 black seats are together. So first I arranged all 10 seats and there are 10 people there. I did not touch people yet. Now I will tell the people to go and sit in those 10 seats. Okay, so when those people will come and sit in these 10 seats, whoever sits in my 2 black seats is my selection. Suppose if I say that, then in how many ways I can select any 2 people who are not together? That is actually the same thing as this, right? Because whoever sits in the black is my selection. So how did I arrange those black seats? In these many ways I arranged, so this becomes the solution. Okay, so if you also do it this way, it is also same thing. But now again there is another method, M3. So the method goes like this. Imagine that instead of black seats, they are actually the flags. Okay, so that means you have certain balls here, there is a flag here, and certain balls here, there is a flag here, and certain balls here. Okay, so here I think 1 ball came as extra. Okay, because total there should be only 8 balls. Okay, now what are these numbers representing? This becomes my x1, which is 3, this becomes my x2 which is 3, this becomes my x3 which is 2, right. So basically these flags are my selection. You can also understand this way, okay. So total there are 10 only, 2 flags and 8 balls, so there are total 10. You can also imagine these flags as black balls, it does not matter. So basically when we apply this idea that x1 plus x2 plus x3 is equal to 8, these are the non-selected members, and when we make sure that these two flags are having at least one gap in between, we are actually selecting two people so that no two are together, okay. So how do we do that? The condition for x1 is that it can be non-negative because our selection come from the first also. That means this flag can come in the beginning place also, and x2 has to be greater than equal to 1, okay, and again x3 can be greater than equal to 0 because this second flag can come at the end also, okay. So now subjected to these conditions, try to solve this question, it's going to give you the same answer, okay. So how do we understand that? We are going to introduce one dummy variable here, x2 dash plus 1 plus x3, this must be equal to 8. So when I send this 1 here, n becomes 7 and the number of variables are 3 here. So go for the non-negative integral solutions. So it becomes 7 plus 3 minus 1c, 3 minus 1 which is same as 9c2, which is also same as that, okay. So this way also using the integral solutions we can solve the problem, okay. So I hope you understood the logic of these three methods here. If you have understood these three methods, try to apply the same method to this question and come in the next lecture, okay. So this way we can solve any problem of selection also using these integral solutions, okay. So with this we will close today's lecture. I hope you enjoyed the discussion and the problem solving techniques. We will meet again in the next lecture with some more interesting ideas. Until then, have a great learning day. Learning shall never stop.